Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from November 2015 question paper. Okay, November 2015 graphs and functions section. So, graphs and function in this question paper, it is question number 4, 5, and 6. Question number 4, 5, and 6. Okay, so I hope all of you downloaded the question paper from our app and then read that question from your question paper and also listen here. Okay, so I hope you will understand clearly. Listen very carefully. Let's start. Question number 4. Given f of x is equal to 2 raised to x plus 1 minus 8. So there is a function given like this. F of x is equal to 2 raised to x plus 1 minus 8. That's all given. Okay, and based on that one we have to answer the following questions. What is the first question? Question number 4.1. Write down the equation of the asymptotes of f. You have to write the equation of the asymptote of f. That is the first question. Asymptote of f. So here what type of equation is that? Is it a linear or a quadratic or a hyperbolic or an exponential function? Which one is that? 2 raised to x, y is equal to a into b raised to x. The variable is as a power. The variable is as a power there. That means plus q. So it means that this one is an, if the variable is coming as a power, then it is an exponential function. So the given one is an exponential function because here you can see that the variable x is as a power. Okay, so here the variable is this x. Okay, that is coming as a power. Here the variable is this x, that is as a power, so it is an exponential function. Now here what is this q stands for? Q stands for the asymptote. Am I right? Okay, so if the question is what is the equation of the asymptote, you are supposed to write y is equal to q. This is the equation of the asymptote of this exponential function. Okay, that means y is equal to this value. That is the equation of the asymptote. So here what is the value of q? Minus 8. So what is the equation of the asymptote? Y is equal to minus 8. That's all. That means y is equal to minus 8 is the equation of the asymptote. Now next question, question number 4.2. What is question number 4.2? Sketch the graph of f, clearly indicate all intersect with the axis as well as the asymptote. So now you have to draw the graph of this f of x. It's a simple question. Sketch the graph of f of x. That is question number 4.2. Okay, so first you have to find the x-intercept and y-intercept. Okay, so here let me find the x-intercept first. Okay, so at x-intercept, what is the value of y? Y is equal to 0. You know that one. At x-intercept, the value of y is 0. Okay, so here substitute this f of x is the same as y. Okay, y is equal to 2 raised to x plus 1 minus 8. So what is y? Y is 0. So it means that we can substitute the value of y as 0. So y is equal to, that means 0 is equal to 2 raised to x plus 1 minus 8. Okay, so now we have to solve this one and try to find the value of x. That is our what we want to find. So to take this minus 8 to this side, so it is going to be positive 8. So it is positive 8 is equal to 2 raised to x plus 1. Now how can you write this 8 as a base of 2? Because you want to find the value of x, the variable, okay, is as a power. So here also we have to write this one the same base. So you know that this 8 we can write it as 2 raised to 3. 2 raised to 3 is the same as 8 is equal to 2 raised to x plus 1. So can you say what is the next step? Okay, here you can see that the bases are the same. Am I right? The bases are the same. So what we can say? It implies that we can equate the exponents. That is, here the exponent is 3 is equal to x plus 1, or x plus 1 is equal to 3. So from there, what is x? It implies that x is equal to, take this 1 to this side, so it is this one positive, on the other side it is negative 1. So what is 3 minus 1? 3 minus 1 is 2. So it means that the value of x is 2. So what is the coordinate now? Coordinate is equal to, x value is 2 and the y value is 0. We are trying to find the x-intercept, so y value is 0. Okay, so that is at the x-intercept. Now what is what we want to find? Y-intercept. So here at y-intercept, what is the value of x? It is 0. Okay, so at y-intercept the value of x is 0. So try to write the equation once more. Y is equal to 2 raised to x plus 1 minus 8. So in this equation we have to write the value of x as 0, substitute the value of x as 0. So substitute here, this is x, so it is 0. So y is equal to 2 raised to 0 plus 1 minus 8. So y is equal to 0 plus 1 is 1. 2 raised to 1 is 2. So it is 2 minus 8. What is 2 minus 8? 2 minus 8 is minus 6. So what is the coordinate? Therefore, coordinate is x value. What is x value first? 0. Y value minus 6. So the coordinate or the y-intercept is 0 comma minus 6. And already in the previous question 4.1 we already find the asymptote, y is equal to minus 8. Now what is this question number 4.2? We have to draw the graph, okay, or sketch the graph. So first we can draw the x-axis and y-axis. This is our x and y axis, this is y, and this one is x. Now first of all we have to draw the asymptote. What is asymptote here? Y is equal to minus 8. So draw the asymptote. Assume that this is minus 8. Okay, this one is minus 8. So first we have to draw the asymptote with a dotted line. Okay, sorry. Okay, so that is the asymptote. Let's write it. It is better to write here y is equal to minus 8. Okay, now let's draw the x-intercept and y-intercept. X-intercept, what is the coordinate? 2 comma 0. x2 is this here 1, this is 1, x2 this is 2. Okay, 2 comma 0 x-intercept. Y-intercept, what is the coordinate? 0 comma minus 6. 0 comma minus 6 means this is y minus 8. Here y is minus 6. That means minus 7 minus 6 somewhere here. Okay, and that is minus 6. So here we got this is the y-intercept and this one is the x-intercept. Now we can draw the exponential. You know the exponential graph shape. So you have to connect that one, and this is our exponential graph. What is the equation? F of x. So that is exponential. So what we want to find? To find the exponent, to draw an exponential graph, you have to first draw asymptote, then you have to draw the x-intercept and y. I mean you have to find the x-intercept and y-intercept, then you have to draw the graph. Okay, so that is question number 4.2. okay, now let's go to question number 4.3. Before I go to question number 4.3, try to understand. I just want to explain something from here, from this question. Look at this one. Here we found the x-intercept and y-intercept, and we got the coordinates 2 comma 0 and 0 comma minus 6. Okay, but in some questions we won't get the x-intercept. Here we got the x-intercept. This is the x-intercept 2 comma 0, but in some questions we don't get x-intercept. This point 2 comma 0 we don't get it. Do you know why? Because let me explain like this. Here if the question is like this, Let me erase it like this one. If the question is like this, instead of this minus 8, this minus 8 is not here, then you don't get the x-intercept. You understand? If that minus 8 or that asymptote is not there, then you don't want to find the x-intercept. Don't forget that. You won't get the x-intercept. Here, if it is not there, what is the number there? You have to understand clearly. That's why I'm explaining, even though that question is not there. Okay, if minus 8 is not there, what we can write? This plus 0. That means what is the equation of the asymptote? Y is equal to 0. Y is equal to 0 means what? Y is equal to 0 means this x-axis. That is y is equal to 0. Okay, and you are supposed to base, our asymptote is going to be the x-axis. Then this graph is going to come like this, either like that or down. Okay, so anyway, if this one is nothing there, if the asymptote is not there, you don't want to find the x-intercept. You just want to find the y-intercept and just draw the graph. Okay, don't forget that one. Now let's go to question number 4.3. Question number 4.3. What is that question? The graph of G is obtained by reflecting the graph of f in the y-axis. Write down the equation of G. Oh, that's a simple question. What is our f of x? F of x is the same as y. Y is equal to 2 raised to x plus 1 minus 8. This is the equation of our f of x. Okay. Now they are saying that the graph of G is obtained by, there is a new graph. What is the name of that graph? G. Okay. The graph of G is obtained by reflecting the graph of f in the y-axis. So if you reflect this f of x graph based on the y-axis, that is called the g of x graph. Okay. So if the reflection is based on the y-axis, reflection based on y-axis, what you are supposed to do? You have to change the sign of x. Am I right? If the reflection is based on the y-axis, you are supposed to change the sign of y. Okay. I mean, if the reflection is based on the y-axis, you are supposed to change the sign of x. Positive x becomes negative x becomes positive x, like that. Okay. So here this is our f of x graph. Okay. So we have to change the sign of reflection based on the y-axis. That means we have to change the sign of x. So that new equation is, they call it as h of x. Okay. So h of x is equal to 2 raised to, I'm going to change the sign of x as minus x plus 1. Other things don't change. Okay. Don't change this sign. Don't change this plus 1 as minus 1. Nothing. Okay. You just change the sign of x. That is reflection based on the y-axis. Just opposite. If the question is to find the reflection based on the x-axis, what you have to do? You change the sign of this y. If the question is reflection based on x-axis, you change the sign of y. Okay, so you have to remember that one. Reflection based on the x-axis, change the sign of y. Reflection based on the y-axis, change the sign of x. That's all. It's an easy question. Okay, so that is our new equation. Y is equal to, or h of x is equal to 2 raised to minus x plus 1 minus 8. So that is question number 4. It's an comparatively easy question, all that for 3 questions, 4.1, 4.2, 4.3. Okay. Now let's go to question number 4, question number 5. Question number 5. What is question number 5 say? Given h of x is equal to 2x minus 3, h of x is equal to 2x minus 3 for minus 2 less than nor equal to x less than or equal to 4. The x-intercept of h is q. So there is a graph given there. So this is the y-axis and this one is the x-axis. Then there is a graph passing like this, and this point, this is q, and here be x comma y, and this point here it is -2, and here it is 4. This is the x-axis, this is the y-axis. Okay, so these are the given things. So here in this is the given graph. Okay, and h of what is the equation of that graph? H of x is equal to 2x minus 3. So 2x minus 3, what is the power of x? 1. That means this is a linear equation. Okay, that's why it is given like this. It's a straight line. Okay, so there is a slight difference from the other questions that we did here in this one. Okay, so other questions is a straight line like this. That means it is going to that side, and this one, this side also, there is no end. Okay, it's a line, that means it's going to both sides. Okay, but here in this question they are specifying from which x value to which x value. From which x value? From -2 to 4. That means this is the end point. There is an end point. It's not continuing like this. Okay, this is an end point. At this point, what is the x value? -2 and up to 4. That means this is another end point, and there the x value is 4. You understand? So here at this point we can say that the x value is -2, and here at this point the x value is 4. We don't know the y values. If we want to find y value, we can find. Okay, let's see what is the next question. What are the things that we want to find? Okay, then if we want, we can find the y. How can we find the y value? We know the equation of that straight line, and if we know the x value, how can we find the y value? We substitute that in the equation, then we will get the y value at that points. Okay, anyway, what is the first question? Question number 5.1. Determine the coordinates of q. That is the first question. Determine the coordinates of q. Q means what? Q is the x-intercept. Am I right? Okay, so you have to find the x-intercept of this one. That is question number 5.1. Okay, determine the coordinates of q. Okay, so here this h of x is a function, so we can write it as y is equal to 2x minus 3, and we know that this q is an x-intercept. So what is the y value? Y value is 0. Okay, so at x-intercept, y is equal to 0. Okay, so here substitute the value of y as 0. Y is equal to, that means 0 is equal to 2x minus 3. Take this minus 3 to this side, so it is positive 3 is equal to 2x. Or what is x? Divide both sides with a 2. Okay, so divide by 2, these two cancel, so x is equal to 3 over 2. Okay, so the value of x is 3 over 2, and what is the value of y? 0. Therefore, what is the coordinate of q? Q is, x value is 3 over 2 and y value is 0. So it means that at this point it is 3 over 2. Okay, so that is question number 5.1. Now let's go to question number 5.2. Question number 5.2. What is that one? Write down the domain of H inverse. You have to find the domain of H inverse. So don't forget that this graph is H of x graph. Am I right? This is our H of x graph. Okay, and here in this graph H of x, what is the domain? Leave that question, 5.2. Okay, what is the domain of this H of x graph, the given graph? What is the meaning of domain? Possible x values. Okay, so here the possible x values are from, in this H of x graph, the minimum x value is -2 and the maximum x value is 4. Okay, so in this H of x graph, the domain is -2 to 4. You understand? Okay, but here the question is, you have to find the domain of H inverse of x graph. Do you understand? Okay, So how can we find the domain of H inverse graph? You have to write the, our question is, what is the domain of this H inverse? That's a question. Okay. So how can we find that one? Okay, so here what we have to do is, first of all, what I'm going to do is, I'm going to find the y values of this point. Okay, so I want to find the y value here and the y value here. Okay, so how can I find the y value? I already told you in 5.1. So what is the equation? Y is equal to 2x minus 3. Okay, at this point, what is the x value? Minus 2. So how can I find the y value? Substitute that minus 2 in this equation. Am I right? Okay, so y is equal to 2 into minus 2 minus 3. 2 into x I substituted as a minus 2, then minus 3. So it is y is equal to, this is my 2 into minus 2 is minus 4 minus 3. That is minus 4 minus 3 is minus 7. So what is the coordinate there? X minus 2 and y now we got as minus 7. So this is the coordinate of that point. So what is here? Minus 7. Similarly, y is equal to, we have to find the y value of this point also. Okay, so what is that one? Let's write it once more. Y is equal to 2x minus 3. So y is equal to, at that point, what is the x value? It is 4. Okay, so I'm going to substitute x value as 4 minus 3. So y is equal to 2 times 4 is 8. 8 minus 3 is 5. So what is the y value? 5. So what is the coordinate now? X value is 4 and the y value is 5. So it means that here the coordinate is 4 comma 5. Okay, so we got that one, the coordinates of this h of x. Okay, minus 2 comma minus 7 and 4 comma 5. Okay, now we can come back to our question. We want this one also to find the answer of our question. Okay, so those who didn't write this one, you have to pause the video and write this one first. Okay, now what is our question? We have to write the in domain of H inverse graph. You have to write the domain of H inverse. That is the question. Okay, so how can we find H inverse graph, or how can we find H inverse? You know, if in a graph, for example, h of x is let me say, in h of x graph there is a point x comma y. Okay, this is a point in h of x graph. Then what about h inverse of x? How can you find the corresponding point? You know, to find h inverse, you already studied that you have to swap x and y. That means this y becomes x and this x becomes y. This is how you want to find the h inverse graph. Okay, so in our h of x, this is h of x graph. H of x graph, here the coordinate is, the last or the first coordinate is minus 2 comma minus 7. So what about h inverse graph? What is the coordinate? For h inverse graph, what is the coordinate? You have to swap x and y. Am I right? So it is minus 7, x becomes y and y becomes x. So minus 7 comma minus 2. Okay, and this point, the last point, what is the h inverse point? H of x, it is 4 comma 5. So what about h inverse? You have to swap x and y. That means in H inverse, that point, this point is going to be 5 comma 4. You swap x and y. Okay, so this is the coordinate of the corresponding coordinate of H inverse graph. This minus 2 comma minus 7 in H inverse minus 7 comma minus 2. Then 4 comma 5 in H of x, H inverse, what is that point? 5 comma 4. Okay, so now here what is the domain? How can you say the domain? Domain is x values. That means here the x value, the minimum x value is minus 7. So it is from minus 7, maximum x value is 5. And this is the domain. X is an element of minus 7 to 5. That is the domain of H inverse of x graph. Okay, so the domain of H inverse of x graph is minus 7 comma 5. That means from minus 7 to 5. That is this is the x value of the first x value. Okay, at this point H inverse graph, x value is minus 7. At this point H inverse, this is the point of H inverse graph, and what is the x value there? 5, the last point. Okay, H inverse graph last point is 5 comma 4. So there the x value is 5. That means in H inverse graph the x value lies between minus 7 and 5, or from minus 7 to 5. So that is question number 5.2. Now let's go to 5.3. Okay, let's go to question number 5.3. 5.3. What is that question? Sketch the graph of H inverse in your answer book. Clearly indicate the y-intercept and the end points. So previous question, do you remember we already wrote the end points of H inverse graph? What are the end points? This end point here, this is H of x, end point is minus 2 minus 7. So what about H inverse end point? Minus 7 comma minus 2. You have to swap x and y to write the coordinates of the inverse graph. Okay, so minus 7 comma minus 2, and this end point H of x graph 4 comma 5. So what about H inverse graph? 5 comma 4. So we can mark these points as the end points of our H inverse graph. Okay, so you swap x and y in this H of x graph. Okay, then you will get the end points of H inverse graph. Okay, so now here we have to find the y-intercept also. Okay, so how can we find the y-intercept in this graph? So look at this one. This H of x is the same as y. Y is equal to 2x minus 3. This is our H of x graph. Okay, so to find H inverse, what you have to do? To find H inverse, what you are supposed to do? You swap x and y. Am I right? Okay, so this y you have to write it as x is equal to this x, you have to write it as y. So it is 2x, you have to write it as, you swap x and y, that's all. Okay, minus 3. So you can't leave the answer like this. You have to write the standard form is always y is equal to, that is the standard form of a function. Okay, so how can we write this one as y is equal to? Take this minus 3 to this side. So it is x minus 3 on this side, it is plus 3 is equal to 2y. So from here what is y? Divide both the sides with 2. So these 2 cancel. So what is remaining here? Y is equal to this one, x plus 3 divided by 2. Now we can see that this is the equation of H inverse graph. Okay, so to find H inverse, what you did? You swap x and y, then you write it in the form of y is equal to. Okay, so let me split. In small classes you studied what is a plus b divided by 2. How can you split this one? In small primary class you studied a plus b divided by 2, that is the same as a by 2 plus b by 2. Right, similarly this x plus 3 divided by 2, how can you write? X by 2. So we can write this one as x by 2 plus 3 over 2. Okay, so it means that this is the equation of H inverse x graph. Okay, so what is the standard form? H inverse is also a linear function, am I right? Straight line function. Okay, what is the standard form of a straight line function? Y is equal to mx plus c. Okay, so what is this c stands for? Y-intercept. So here what is the y-intercept? 3/2. So it means that in our H inverse function the y-intercept is this 3/2. You understand? Okay, so the y-intercept is 3/2 and end points are -7, -2 and 5 comma 4. You swap x and y to remember that one. Okay, so based on that one we have to draw the graph. Okay, so let's draw the graph. Do we want this equation once more? Okay, we want, okay, let me draw it here quickly. This is the x-axis. You have to draw it neatly. This is the y-axis and -7, x -7, y -2 somewhere here. Okay, assume that this is -7, so -2 somewhere here. This is -7 comma -2. This is -2 and this one is -7. So this is the point. Now 5 comma 4. Okay, assume that this is x5 and this is y4. So the point is somewhere here, that is 5 comma 4. Okay, now the y-intercept is, what is the y-intercept? 3/2. So 3/2 means 1.5 somewhere here. Okay, then you have to join that two line. This is 3/2, the y-intercept 3/2. Then join that 2 points and this is the our H inverse x graph. Okay, so y-intercept is 3/2, end points -7, -2 and 5 comma 4. Okay, so that is question number 5.3. now let's go to question number 5.4. okay, question number 5.4. 5.4, what is that one? For which values of x, that means you have to find the values of x. Okay, then what is the condition? H of x is equal to H inverse of x. H of x is equal to H inverse of x and you have to find the values of x. So do you remember our H inverse of x equation in the previous question? X plus 3/2 or something like that. Yeah, x plus 3/2. Okay, so this is our H inverse of x equation from the previous question 5.3. Okay, now you, in this question you have to find the values of x satisfying this condition. Okay, so what is our H of x graph? What is our H of x equation? 2x minus 3. So it is 2x minus 3 is equal to, what is H inverse of x equation? We got from the previous question, that is x plus 3 divided by 2. Okay, so from here we have to find the values of x. So cross multiply these two, you can multiply here. So it is 2 into 2x minus 3 is equal to x plus 3. Now just solve this one and find the value of x. Okay, so 2 into 2x is 4x, 2 into minus 3 is minus 6 is equal to x plus 3. Take this x to this side. So it is 4x minus x is equal to, there is a 3, take this minus 6 to the other side. So it is plus 6. 4x minus 3x is 4x minus 1x. 4 minus 1, 3. That is 3x. 3 plus 6 is 9. So what is x? 9 divided by 3 and x is equal to 9 divided by 3 is 3. So it means that the value of x is 3. Okay, that's a simple algebra. You just pause the video and try to do alone. Okay, and check your answer is correct or wrong. Okay, it's a grade 8 algebra section. Okay, so that is question number 5.4. now let's go to question number 5.5. Okay, let's go to question number 5.4. Question number 5. First question number 5.5. Question number 5.5. What is that question? P x comma y is the point on the graph H that is the closest to the origin. Calculate the distance OP. So here we can see that there is a point given p x comma y, okay, and here you have to find what they are saying, that this point p is closest to origin. What is the meaning of that? The distance between that OP is the minimum. What is the meaning of that one, guys? Before we go to that one, here if I draw only that part, okay, this is that part, okay. So here p can be, this is the origin. So what is the coordinate at the origin? 0 comma 0, am I right? Okay, and p can be either here, okay, or here, or here, or here, or here, or here, or here. You understand? We can be anywhere. Okay, so only one condition: the distance between this O and this P must be minimum. So maybe if I write a P here, maybe this distance is 3 centimeter. I'm just giving an example. Okay, but if I write a P here, assume that this is the P. Okay, then this one is a 3, let's say 2.7 centimeter. Okay, and if I write a P here, maybe this one is 2 centimeter, then again this one is 2.7 centimeter, this one is 3 centimeter. So you can see that the closest to the origin, is this one, this point. You understand? Okay, so that is the meaning of that closest to origin. The P must be closest to, P can be anywhere, okay, but only one condition: it must be that P must be closest to origin, or the distance between O and P, or the center and this P must be the small. Okay, so if here it is 3, if here it is 2.7, and this one is 2, which one is the closest? This 2 is the closest. OP is 2 is the closest. Okay, like that. Okay, so here look at that question once more. 5.5, px comma y is the point on the graph of H that is closest to the origin. Calculate the distance OP. You have to find the, if it is that condition, you have to find the value of O, or the distance between O and P. Okay, so this is the point O, that is the origin coordinate is 0 comma 0. Okay, so now before I go to that question, I want to explain one more thing, then we can do that question. Okay, x, assume that x squared is equal to 25. What is x? Root of 25. Okay, leave minus case. What is x? X is equal to root of 25, that is 5. Okay, then x squared is equal to let's say 16. What is x? X is equal to square root of 16, that is 4. Okay, I'm not considering the minus case now. Okay, then x squared is equal to let's say 9. What is x? X is equal to 3, square root of 9, 3. Okay, now look at this one. To get a smallest value of x, here x is equal to 5, x is equal to 4, x is equal to 3. Okay, to get a smallest value of x, this x square must be smallest. Which one is the smallest here? X square, 25, 16 or 9? 9 is the smallest. Do you understand? Okay, so to get the smallest value for x, x square must be smallest. To get the smallest value of x, here the x value is 3, that is the smallest value of x here. 5, 4, 3, this is the smallest value. Why we get the smallest value there? Because in these x square values, this x square value is the smallest. You understand? So to get the smallest value of x, it means that the x square value must be smallest. Okay, so to get now listen very carefully. Okay, to get the minimum distance of OP, to get the smallest distance of OP, it means that OP square value must be the smallest. Do you understand? To get the smallest distance of OP square value must be smallest, like this. Okay, fine. Okay, now one more thing. What is the distance formula? Distance formula you studied root of x1 minus x2 the whole square plus y1 minus y2. In analytical geometry you studied this formula. d square. Okay, so in our case OP, d is distance means OP. Okay, so in our case it is OP. So OP is equal to root of x1 minus x2 the whole square plus y1 minus y2 the square. So if I want to find OP square, I have to remove this one. You know that one. Okay, so this is x1 minus x2 the whole square plus y1 minus y2 the whole square. I remove that bracket or square both sides, whatever maybe. Okay, so that is OP square. Okay, so to get the smallest of OP square, I mean sorry, to get the smallest value of OP, this OP square value must be smallest. Listen once more. To find the smallest value of OP, or the smallest distance or the closest distance between O and P, okay, what must be small? OP square must be small. Okay, so we are using that concept here in our question. Okay, so leave all that one. Now come back to our question. So what is OP square now? What is OP square? I am going to find the distance between O and P. Okay, so I am trying to find OP square. Okay, so what is OP square is equal to, we don't want to put a square root because it's OP square. Okay, so here OP square is x1 minus x2 the whole square. So it is x minus 0 square plus y1 minus y2 square. So y minus, that one is also 0 because it's origin, y minus 0 the whole square. Okay, so OP square is equal to x minus 0 means x square plus y minus 0 is y square. So OP square is equal to x square plus y square. Okay, okay, now here OP square is equal to x square plus y square. Okay, so what is this y? Where is this y? Y is a point on this straight line g h of x. Am I right? This point is a point on the straight line. So there, what is y? We know the equation of the straight line, that is h of x is equal to 2x minus 3, and we know that this h of x is the same as y. Okay, so at this point, what is y? What is this y? Y is 2x minus 3. At this particular point, we know the equation of that point is a point on the straight line h of x. Okay, and we know the equation of the straight line y is equal to 2x minus 3. So it means that this y is the same as 2x minus 3. You understand? So here OP squared is equal to x squared plus y squared, and we know that at that point y is 2x minus 3. So we can substitute OP square is equal to x square plus y. At this particular point, what is y? Y is 2x minus 3. Okay, so it is 2x because that point is a point on that h of x graph. Okay, so now we can expand that one and simplify. OP square is equal to x square plus, if we expand this one, it is like this, a minus b the whole square. Okay, what is that? First term square, a square minus 2 into first term into second term, 2 into first term into second term plus second term, this is b, second term square, that is plus b square. So similarly, how can we expand this one? First term square, 2x square, that is 4x square, minus 2 into first term into second term, 2 into 2x into 3. So 2 into 2 is 4, 4 into 3 is 12, then x plus b square, second term square. Here second term is 3. 3 minus 3 square is 9. Okay, so that is op square. So op square, we have to simplify that one. X square plus 4x square, like term, that is 5x square minus 12x plus 9. So that is the equation of op square we got. Okay, now here in this equation I'm going to apply the one that I said before. Okay, so what is our question? Look at the question once more. What is the question? What is the question? P of xy is a point on the graph of h, that p x comma y is a point on the graph of h that is closest to the origin. Calculate the distance of OP. Okay, so this is the expression for OP square. Okay, so we have to find the smallest or closest distance between O and P. Okay, so to find the smallest value of OP, to find the smallest value of OP, that is our question. Okay, OP square must be small. Okay, so or it is enough to find the smallest value of this OP square. To find the smallest value of OP, it is enough to find the smallest value of this OP square. That is the meaning. Okay, so now I'm thinking I got an expression for OP, that is OP square is equal to 5x square minus 12x plus 9. Okay, so I have to find the smallest value of this OP square. That is going to be the smallest value of OP also. Okay, so how can I find the smallest value for the minimum value of OP? Okay, smallest means minimum or closest or minimum. Okay, so how can I find the minimum value of that distance OP? So for that we have to go to calculus section. Calculus section, do you remember you studied to find the smallest and the biggest, the first derivative is equal to 0. Okay, so that section, that calculus part we are going to apply here to find the smallest value. Okay, so what I said, to find the smallest value, what we have to do, the first derivative of that OP square is, first derivative in terms of x is equal to 0. How we can write it like this? This is OP square. Okay, first derivative of OP squared is equal to 0. Why? Because in calculus you studied to find the minimum or maximum. Minimum means smallest. Okay, the first derivative is going to be 0. Okay, so we are going to apply that one here. Okay, first derivative, let's try to find the derivative. 2 into 5, 10x. I hope you know how to find the derivative. Okay, so this 2 becomes here, so 2 times 5, 10x. What is the derivative of minus 12x? Minus 12. What is the derivative of 9? Constant term, 0. Okay, those who doesn't know, you have to watch that calculus section. Okay, so 10x minus 12, and first to find the minimum OP square, the first derivative is equal to 0. So this one is equal to 0. So from here, what is 10x? Take this 12 to the other side, so it is positive 12. So what is x? 12 divided by 10. That means the value of x is 1.2. Okay, so to find the smallest value of OP, the value of x is 1.2. So now what is the question? We have to find the smallest value. Am I right? Okay, we have to find the smallest value of OP. So this is the expression for OP square. This one is the expression for OP square. So to get the smallest value, what is the value of x? 1.2. So we have to substitute this 1.2 in this equation, then try to find the value of OP. Okay, so when it is small, when OP square is small, what is the x value? 1.2. So how can you find the smallest distance now? Substitute this x value in this equation, then you will get the smallest distance of OP. Okay, so let's substitute that in that equation. So what is OP square? OP square is equal to 5x square, 5 into 1.2 square, sorry, it's not plus it's a minus 12 into x. X is 1.2 plus 9. So check in your calculator what is the answer for that one. In your calculator you will get a 9 over 5. 9 over 5. So what is OP? OP square is 9 over 5. So what is OP? Root of 9 over 5. So check in your calculator. It is 1.34. That means the smallest distance between units. The smallest distance between O and P is 1.34 units. Okay. So you can see that this question is a combination of these graphs and function and calculus section ideas. Okay. So that is question number 5.5. Now let's move to 5.6. Question number 5.6. What is that question? Given h of x is equal to f dash of x, where f is a function defined for minus 2 less than or equal to x less than or equal to 4. Okay. So there is a given h of x is equal to f dash of x, where f is a function defined for minus 2 to 4. Explain why f has a local minimum. You have to find why f has a local minimum. So, okay, let me first erase that graph, our given graph. Then I want to explain something more to do this type of questions. Okay, so listen very carefully. Before I come back to this question, you have to understand something from calculus section. Okay, so how many of you remember in a calculus graph, let me draw with a red pen. Do you remember this what is this equation? This is a cubic graph, am I right? Okay, and in this cubic graph, what is the name of this point? That's a point of inflection. Do you remember that one? This point is the point of inflection. Okay, so here I'm not going to explain much more on that one. You have to watch calculus section. Okay, just a recap what you studied in calculus section, that's all. Okay, so this is the point at which concave down changes to concave up. So at this point of inflection, do you remember what is the second derivative? At that point of inflection, the second derivative is equal to 0. You remember that one, guys? Okay, second derivative is equal to 0. What is this portion? This is concave down. You remember I told you like this. Okay, when the mustache is like this, it is concave down. So when it is concave down, what is the condition? Second derivative is less than 0 or the negative. Okay, and when it is concave up, this is concave up. Okay, mustache is like this, then what is the condition? Second derivative is greater than 0 or positive. Okay, so if you get the answer of second derivative as positive, then you have to know that this is the shape of the graph. Do you understand? If you get, let me repeat once more, if you get the second derivative as a positive number, greater than 0 means positive. If you get the second derivative as a positive number, you have to understand that that is concave up, or the shape of the graph is like this. Fine, up to there. So this is the condition. This is concave down, second derivative is negative. That means if it is negative, this is the shape. At the point of inflection, second derivative is equal to 0. When the second derivative is positive, then this is the shape of the graph. Okay, now what is our given equation? H of x is equal to f dash of x. Okay, now here what is our h of x? That is our given graph, straight line graph, 2x minus 3. Okay, so we can substitute that h of x as 2x minus 3 is equal to f dash of x. Do you understand that one? That means f dash of x, let me write it like this, f dash of x is equal to 2x minus 3. What is the meaning of f dash of x? First derivative is equal to 2x minus 3. First derivative of a graph is 2x minus 3. Okay, so now again we have to go back to that quadratic, cubic function calculus section. Okay, so if this is a cubic graph, what is the name of these 2 points? Turning point. Okay, so there, do you remember at this turning point what is the first derivative? First derivative is equal to 0. At this turning point also first derivative is equal to 0. You remember that at turning points the first derivative is equal to 0. Now look at this one. F dash of x stands for first derivative, and what is our first derivative? 2x minus 3. So how can we find the turning point x value? F dash of x is equal to 0 implies that this 2x minus 3 is equal to 0. So take this minus 3 to the other side. So it is 2x is equal to 3. What is x? X is equal to 3 over 2. It means that the turning point of this graph f dash of x is equal to 3 by 2. Okay, now just hold on that one. We got the turning point or x value of the turning point, that is 3 over 2. Just wait there. Okay, now try to understand like this also. Here if I draw a graph like this, okay, it's a parabola. Okay, what is this point? Yeah, of course it's a turning point. And is it a maximum turning point or minimum turning point? This is the maximum turning point. If the parabola is like this, and what is this point? It's a turning point. Is a maximum or minimum? This is a minimum turning point. Okay, this is a minimum turning point, and this one is the maximum turning point. Okay, fine. Now what is our f dash of x? Look at our f dash of x graph. F dash of x, what is the equation? F dash of x is 2x minus 3. Okay, so f dash of x is equal to 2x minus 3. I'm trying to find f double dash of x, second derivative. So what is that one? 2x minus 3, second. What is the derivative of 2x? That is 2. And what is the derivative of minus 3? 0. Constant term derivative is 0. That means f dash of x is equal to 2. 2 means positive or negative? Positive. So it means that that is greater than 0. So what is the meaning of that? It implies that f double dash of x, second derivative, is greater than 0. Okay. Second derivative is greater than 0 means what? The shape of the graph is like this. You understand? Okay, so I already told you, if the second derivative is positive, greater than 0 means positive. If the second derivative is positive, then the shape of the graph is like this. Okay, so it means that what is the turning point x value? 3 over 2. From here we got the turning point x value is 3 over 2. Okay, so it implies that the, what is our question? Look at the question once more. F double dash of x, given h of x is equal to f dash of x, where f is a function defined on that one. Explain why f has a local minimum. So now here we can write that it implies that f double dash of what is x at that turning point? 3 over 2 is greater than 0. So at this turning point, what is x value? 3 over 2. Okay, so that is the meaning of this f double dash of 3 over 2, and we know that second derivative is greater than 0. Okay, so here we are saying that second derivative at the value of x, the turning point, is greater than 0. What is the meaning of that? It implies that f has local what? Local minimum. Okay, f double dash, listen once more, second derivative is greater than 0 means the shape is like this. Okay, and here what we are trying to say, second derivative of when x is equal to 3 over, we know that x is equal to 3 over 2 is a turning point. Okay, so second derivative of x 3 over 2 is greater than 0. Greater than 0 means what? At this point 3 over 2 turning point, the shape is like this. Okay, so what is the meaning of the, if the shape is like this, what is the meaning of that? F has a local minimum. Okay, so that is question number 5.6.1. this is question number 5.6.1. okay, now let's go to question number 5.6.2. Okay, question number 5.6.2. 5.6.2. What is that question? Write down the value of the maximum gradient of the tangent to the graph of f. Wow, wow, wow. What is that one? Write down the value of the maximum gradient of the tangent to the graph of f. Wow. What is this f graph? We already said that it is given, previous question it is given that h of x is equal to f dash of x. So then h of x, we know that 2x minus 3 is equal to f dash of x, and there we wrote f dash of x is equal to, this is the same as f dash of x is equal to 2x minus 3. That means second derivative, not second derivative, first derivative is 2x minus 3, a linear function. So what about the f of x graph? If I write, look at this one, if I write it like this, f of x is equal to x squared minus 3x plus 5. I'm just giving an example, not compared to this one. Okay, then what about this? Is a, what type of graph is this? X square, that is a quadratic graph, am I right? Okay, so that one is a quadratic graph, and if I try to find the derivative, what is that one? X square derivative is 2x, minus 3x derivative is minus 3, constant term derivative is 0. Okay, so it means that to get a linear function as a second derivative, first derivative, the original function is going to be a quadratic function, or you can say like this, if you derive a quadratic function, what you are going to get? A linear function. Okay, so here f dash of x is a linear function. So what about f of x? That is a quadratic function. Okay, f dash of x is a linear function. So what about the original f of x function? That's a quadratic function. Okay, so listen once more. In effect, that is all. If you derive a quadratic function, you are getting a linear function. So here a first derivative is linear. So what is the original graph? It's a quadratic function. Okay, so here previous question we already said that, or we already proved that this f of x is having a local minimum. That means the shape of the graph is like this, am I right? Okay, so in our question the shape of the quadratic graph f of x is like this. This is a f of x graph. Okay, and here we already find that the turning point is at that turning point, what is the x value? 3/2. Okay, at the turning point x value is 3/2. So this is our f of x graph, and here the turning point x value is 3/2. We don't know what is the y value. Okay, leave it. Now here before I go to that question, okay, let me complete that one. Look at this one. Look at our question, this question 5.6. look at your question paper. Given h of x is equal to f dash of x, where f is a function, this is our f of x, quadratic. Okay, f is a function defined for -2 to 4. So this is not a function like this, it is continuing to that side and this side. It's not like that. Okay, in this one question they are saying that the maximum value here, it is x value is -2, and here it is 4. You understand? So it means that at this point and this point, okay, here what is the x value? X value is -2, and here what is the x value? It is 4. Okay, minimum value is -2, the minimum point x value is -2, and the maximum point x value is 4. Do you understand that? Okay, now listen here. Now I'm not going to explain this question. You have to understand one more thing to answer that one. Okay, so listen very carefully. Let me draw a parabola like this. Okay, now if I draw a straight line like this, that's a gradient. What is a gradient? Negative or positive? Negative, am I right? Okay, and if I draw a line like this, what is a gradient? Positive. Okay, which one is bigger, negative gradient or positive gradient? Of course, positive gradient is bigger. Here, for example, gradient is equal to -3. Here, the gradient is equal to 1. Which one is bigger? Of course, 1 is bigger than -3. Am I right? So, positive gradient is bigger. Okay. Now, here, if I draw a gradient at this point, a tangent or a gradient. So, here, this is the gradient. Okay. Now, when you go down here, if I draw a gradient here, this is the gradient. Can you see? Gradient means slope. Can you see the slope is decreasing? Okay. Then if I draw a gradient, a tangent here or a gradient here, can you see the slope is again decreasing? Okay. Then if I draw a tangent here, a slope, that is a positive gradient now. Okay. Now this one is negative gradient. Is a okay. And now if I draw here, that is a positive gradient. Now we can see that it is increasing now. Okay. If I draw a gradient tangent here, and what is the gradient? It's bigger. Okay. If I draw a tangent here at this point, again the tangent is increasing like this. It is like this, then it is coming like this, coming like this, coming like this. Okay, that means the slope is increasing or the gradient is increasing. Okay, so where you will get the maximum gradient at this point, at that point you will get the maximum gradient. Am I right? Not at this point. This point, if I draw the tangent is or slope is going to come like this, and that is a negative gradient. Negative gradient is not bigger. Positive gradient is going to be bigger. So here, if I want to get a maximum gradient, the tangent must be somewhere like this, passing through this point. Am I right? So at that point, what is the x value? It is 4. To find the maximum gradient, the gradient must pass or the tangent must pass through the maximum point here. And it is given that at this maximum point, the x value is 4. Okay. So now listen to our question. Look at our question once more. Okay. Now what is our question? Write down the value of the maximum gradient of the tangent to the graph of f. So you have to write down the value of the maximum gradient. You have to find the value of the maximum gradient and to the tangent to the graph of f. So we have to find the gradient of this one. Okay. So now in calculus section, you studied in a curve. In a curve, how can I find the gradient of that straight line? First, I have to find the derivative of this curve, then substitute the x value of that point. Am I right? Do you remember that one? There is a curve like this. Okay, there is a curve like this. Okay, whatever, it doesn't matter, cubic or a quadratic or anything. Okay, and there is a point here, and there is a tangent like this. Okay, how can I find the gradient of that tangent? First, I want to find the derivative of this curve, then substitute the x value. Do you remember in calculus section? Okay, so here we know that equation, the derivative of this function. We know this is f of x function. Okay, so not this one. We know the derivative. What we are supposed to do? The derivative of this function. And what is the derivative of the function? F dash of x. Do you remember we wrote it here? F dash of x is 2x minus 3. Okay, you remember it is given like this in that question. H of x is equal to f dash of x, and this h of x is 2x minus 3, or f dash of x is 2x minus 3. That is this one. So this is the derivative of this curve. Okay, and to find the gradient of the tangent, what you are supposed to do? Find the derivative. So this is the derivative, and in that derivative you have to substitute the x value. So I already told you, to get the maximum gradient, you are supposed to take that point. So at that point, what is the x value? It is 4. So it means that here we have to substitute the x value as 4. To find the gradient of this tangent, first to find the derivative. We know the derivative. This is the derivative. In that derivative, you are supposed to substitute the x value. So in our case, at that point, what is the derivative? What is the x value? 4. So substitute the 4. So it is 2 into 4 minus 3. That is 2 into 4 is 8. 8 minus 3 is 5. Okay. So the maximum, the value of the maximum gradient is 5. Okay. Yeah, that two questions are tricky questions. I tried my level best to explain. Okay, so if it is too difficult, just ignore that one and continue what. Okay, don't waste too much time for this type of questions. Okay, but depends on you. If you can understand clearly, then it's fine. Try to watch again and try to drill that in your mind. Try to understand. Okay, yeah, that's a higher order question. Question number 6. Next question number 6. Okay, question number 6. The graph of f of x is equal to minus 2x square plus 18. So there is a graph given, f of x is equal to minus 2x square plus 18, and another graph is given, g of x is equal to ax square plus bx plus c, as sketched below. Okay, let me draw that graph. This is the x and y axis. Okay, so these are the two graphs given, f of x, this one is f of x and this one is g of x. Okay, the black one is f of x and the blue one is g of x. Okay, so look at this equation, f of x is equal to minus 2x square. X square means it's a quadratic. Okay, g of x, ax square, that one is also a quadratic. So it's not a, when I look at this graph at the first time I thought it's a cubic graph. Okay, but it's not like that. It's a two quadratic graph is given. Okay, one is f of x graph and the other one is g of x graph. Okay, now p and q are the x-intercepts of f. These p and q are the x-intercepts, and q and r are the x-intercept of g of x, and y-intercept, okay, is a t, etc, etc. Okay, now let's go to the first question, 6.1. Question number 6.1.1. What is that question? Write down the coordinates of t. You have to find the coordinate of this point t. Actually, what is that point t? T is the y-intercept. Am I right? Okay. Y-intercept of which graph? Y-intercept of this f of x graph. Am I right? Okay. What is f of x graph? Write the equation once more. Minus 2x square plus 18. Okay. So what is the y-intercept in this graph? This 18 is the y-intercept. So how can you write the coordinate? Y-intercept means the value of x is 0. X is 0 and y-intercept, y value is 18. So the coordinate of t is 0, 18. Okay. Next question, 6.1.2. What is that question? Determine the coordinates of q. What is that point q? Q is the x-intercept of this f of x graph. Am I right? Okay. So at x-intercept, what is y? 0. Okay. So write once more that equation, f of x is equal to, that is the same as y is equal to minus 2x square plus 18. This point q is the y-intercept. That point q is the x-intercept. So what is y? Y is at x-intercept, value of y is equal to 0. So substitute y is equal to, that is 0 is equal to minus 2x square plus 18. Take this minus 2x square to this side. So it is 2x square is equal to, positive 2x square is equal to 18. So from here, what is x square? Divide throughout both sides with 2, or take this 2 to the denominator. 8 divided by 2. In all the ways it is 18 divided, not 8, 18 divided by 2, that is 9. Okay. So what is x? Square root of 9. So x is equal to plus or minus 3. So which value is correct? Plus 3 or minus 3 for this q? Here this is the origin. So q is positive side. That means q, therefore q is 3, x-intercept y is 0. So here the value of x is 3, or that coordinate q is 3 comma 0, and here what is the coordinate 0 comma 18. Okay. So that is question number 6.1.2. Now let's go to 6.1.3. Question number 6.1.3. What is that question? Given that x is equal to 4.5 at s. So at this point s, it is given that x value is 4.5. Okay, and what do you want to find? Determine the coordinates of r. If it is like that, at this turning point s, the x value is 4.5. We don't know what is the y value, and what is the question? You have to find the coordinates of r. Okay, so it's a very easy question. You know, if I draw a parabola like this, or a quadratic function like this, okay, you know that this is the turning point, and what is the name of this line? That is the axis of symmetry. This line is axis of symmetry. Okay, so that line is known as axis. What is the meaning of axis of symmetry? Axis of symmetry means that this distance and this distance are same. If this one is 2, this one is also 2, like that. Okay, that is the axis of symmetry. Okay, so here axis of symmetry always passes through the turning point. Okay, so in our question here it is given that the x value is 4.5, and at this point what is the x value? It is 3 comma 0, and you have to find, this is our point q. Okay, this is the point q, and this is the point r. Okay, so here you have to find what is the x value. So it's very easy. Let's call this as x comma y. Okay, so you know that when you add this 4.5 is going to be the middle of these 2 points. Am I right? Okay, so because the axis of symmetry passes through the turning point. What is the meaning of axis of symmetry? This distance and this distance are the same. Okay, these two distances are the same. So it means that this, at this point 4.5, here the x value is 4.5. Okay, so how can you find this middle point 4.5? You add this one, midpoint formula. Okay, so if you add x plus 3, x value here 3. Okay, so x plus 3 divided by 2, you are supposed to get 4.5, because you know that this is the middle point. Okay, these two distances are the same. So how can we write x plus this 3 divided by 2? I'm applying the midpoint formula, and what is the answer we are supposed to get? Here what is the x value? It is 4.5. Here the x value is 4.5, means here also x value is 4.5. So here it is 4.5. So from there, what is x plus 3? You cross multiply this one. 2 times 4.5, that is, check in your calculator, it is 9. So what is x? 9. Take this 3 to the other side, so it is minus 3. So x is equal to 6. So that is the x-intercept. So what is the y value? Y value is 0. So it means that therefore coordinates of r is 6 comma 0. Okay, so that is question number 6.1.3. now let's go to question number 6.1.4. 6.1.4. Determine the value of x for which g double dash of x is greater than 0. You have to find the value or values of x. Okay, and what is the condition? G double dash of x is greater than 0. Okay, you have to find the values of x where g double dash of x is greater than 0. Find the values of what? X. Okay, so x means this one, this is the x-axis. Okay, you have to find the values of x where g double dash of x is greater than 0. Okay, so Yeah, now look at that g of x graph. Before I start that one, look at the g of x graph. What is the equation? Ax square plus bx plus c. And look at our g of x graph. The shape of this g of x graph is given like this. It means, what is the meaning of that one? It means that the value of a is positive. Am I right? Okay, so the value of a is positive. That is why the shape of the graph is like this. Okay, now let's try to find g dash of x first derivative. Okay, what is that one? This is g of x, so 2 into a 2ax. What is the derivative of bx plus b? What is the derivative of constant term? It's a 0. That is the g dash of x. Okay, then second derivative, g double dash of x. What is the derivative of 2ax? X is the variable, so derivative of 2ax is 2a. Derivative of the constant term is 0. That means g double dash of x is 2a, and I already told you a is positive. Am I right? Okay, that means g double dash of x is a positive number. G double dash of x is a greater than 0. Okay, g double dash of x means that is a g of is a function. Okay, whatever second derivative or first derivative or a given function, g of x, g dash of x, g double dash of x, always almost all of that one representing a function. Am I right? Okay, and here g double dash of x is a constant number. 2 into a means a number. Okay, 2 into a constant number, and also at the same time that is a positive number. Okay, so before I write the answer, try to understand like this. Listen here, this is the x and y axis. Okay, at this point. Okay, so if I want to write y is equal to 5, if I want to draw the graph of y is equal to 5, how can you draw? Y is equal to 5 means this is the x-axis, and assume that this is the point 5, y5. That means above x-axis this is positive, this one is positive, and above x-axis. Okay, and this is the line y is equal to 5. You understand? So here 2a is positive means that it's a above x-axis, it's a positive number. A is positive, so 2 times a positive number is positive. Okay, that means above x-axis. Okay, above x-axis. And how can you draw that graph? 2a, it's a straight line, it's a positive number. Y is example, y is equal to 5, y is equal to, let's say, 7. How you are going to draw? You are going to draw a straight line passing through 7. Am I right? Okay, so here you can see that all of this positive, this is also positive. Here this one is going to that side, both sides. Okay, so what is our question? We have to find the values of x. That is the question. Am I right? We have to find the values of x. So we can see that g double dash of x is positive, or here also given it is greater than 0. That means the line is a parallel line x-axis. Okay, that means it can take any, this is the x value, right? It can take any real number on the number line. This is the x-axis. Am I right? This, if it is a positive, it can take any real number because it is going parallel to the x-axis, to both sides. Okay, so what is our answer? X can take any real number, doesn't matter, because g double dash of x is a positive constant number. That means it is going parallel to the x-axis to both sides. That means x can take any real number, or you can write it like this also. X is an element of minus infinity to positive infinity. Okay, so that is question number 6.1.4. It's a 2 marks. Now let's go to question number 6.2. Question number 6.2. The function defined as y is equal to a divided by x plus b plus q. So there is a function y is equal to a divided by x plus b plus q has the following properties. The domain x is an element of R, x not equal to minus 2. So the domain means possible x values. Okay, so First property is x is an element of R. That means x can take a domain. Domain is x value. Okay, x can take any real number, but what is the condition? X not equal to -2. X not equal to -2. Immediately you can understand one thing, that -2 is a vertical asymptote. Okay, so if the graph is like this, and if here it is -2, then that -2 is the vertical asymptote. That is the meaning of x not equal to -2. Okay, now second point, y is equal to x plus 6 is an axis of symmetry. Okay, before that one, what type of graph is this? A divided by x plus b is a hyperbolic graph. Don't forget that. When you see the structure, the variable is the denominator. That means it's a hyperbolic function. Okay, so either the shape is like this, or it is like this. Okay, so any one of these shape. Okay, now let's see what is the shape. Okay, now before that, y is equal to x plus c is the axis of symmetry. Okay, so do you remember in the class you studied like this? Axis of symmetry always passes through the what? Axis of symmetry, if axis of symmetry, okay, look at this one, this is the asymptote. Okay, and assume that this is another asymptote. Okay, then where the axis of symmetry is passing? Axis of symmetry always passes through the intersect of that asymptote. Okay, so here it means that y is equal to 1, positive 1. That means gradient is positive, so axis of symmetry is an increasing axis of symmetry. So it is like this. This is the axis of symmetry they are talking about. Y is equal to x plus 6. You understand? Okay, so anyway, this is the axis of symmetry. You have to understand that axis of symmetry always passes through the intersecting point of the asymptotes. Okay, so here in this case, this is our asymptote. Am I right? Okay, let me draw it. Okay, so this is our vertical asymptote. We don't know what is a horizontal asymptote. We are trying to find that one. Okay, anyway, there is an axis of like this. There is a, we don't know what is, we have to find that one, what is that point. Okay, so anyway, the axis of symmetry is passing through, is supposed to pass through that, this point. Am I right? And they are given that this is the y-axis, and it is given that this equation of this one is x plus 6. 6 means, don't forget that this point is y-intercept is 6. Okay, now equation of that axis of symmetry is y is equal to x plus 6. Okay, now how can we find the horizontal line then? This asymptote, you know, at this particular point, what is the x value? -2. That point is a point on that axis of symmetry. Okay, so at this point, what is the x value? -2. Okay, so how can you find the vertical asymptote equation? You have to substitute x value as -2. So x -2 plus 6. That means -2 plus 6 is 4. So it means that here the asymptote is 4. Okay, now look at the next one. So we got both the asymptotes, vertical and horizontal asymptotes. Okay, now look at the next bullet. The function is increasing for all x is an element of R, x not a. It's an increasing function. Increasing function means what? If this is the x and y axis, this is an increasing function. This one is an increasing one. Am I right? If I draw it like this is a decreasing one. This one is a decreasing one. It's going down. Okay, this one is an increase. Then last bullet is, it's an increasing function. That means it is supposed to come here and here. Okay, so that is the What is the question now? Draw a neat sketch graph of this function. Your sketch must include the asymptotes, if any. So here you can see that you included the asymptotes, okay, and they are not saying anything about the x-intercept and y-intercept, or we don't have enough information to mark x-intercept and y-intercept, okay. So just listen once more. X not equal to -2 means that is a vertical asymptote, okay, and this is the equation of axis of symmetry. So try to understand, axis of symmetry always passes through the midpoint of the asymptote. So the equation of this axis of symmetry is given as y is equal to x plus 6. So that is a y-intercept is 6, and at this point what is the x value? We know that -2. So how can you find the y value of that point? You substitute that x value in the equation. So y value is 4, and it is also given that it is an increasing function. So it is an increasing function, okay. So that is question number 6.2, and that's the end of November 2015 question paper. So guys, you can see that's a lengthy one, okay, and there are some tricky questions also in that question paper, in this one, okay. So listen, repeat, watch again, and try to understand that one clearly, okay. So I hope you enjoyed the class. It's a long section, sorry for that. So see you on the next class.